This is for help in problems 2 through 8 on the review sheet on exponents. So in problem number 3, you'll see that we have base that's x. We have exponent here of squared. This one has an exponent of 4, but the exponent of 4 is being raised to another exponent, so we have power to a power. The rule was that you are going to multiply those out, so we end up with x squared times x to the negative 8. Since now we are multiplying like bases, they both have base x, we add the exponents, and we have x to the negative 6. Remember, this negative exponent means you could also have the reciprocal of the base, so the reciprocal of x is 1 over x, and so we have all of that being raised to the 6, but that just ends up being just the x is raised to the 6. Next problem we have, again, all just y's in this problem, but here we've got 1 over y squared, and 1 over y squared can be written as y to the negative 2. Now we're multiplying all like bases, so we're going to add those exponents, and we end up with y to the negative 1. But once again, we have this negative exponent, so we can write that as 1 over y to the first, or 1 over y. In problem number 5, we see that we've got this 1/3, and 1/3 we could take this and write this as 3 to a negative exponent, and since the exponent is 2, it's 3 to the negative 2. Now we have a base 3, a base 3, and a base 3, so since we're multiplying like bases, we're going to add the exponents, and we have 3 to the 6th. In problem number 6, we have these two parts here, 3 cubed and 4 to the negative 6, all being squared. And so this is essentially saying that we have powers being raised to another power, which is multiplication. So we're going to distribute that 2 to both of the exponents, and we end up with 3 to the 6th and 4 to the negative 12th, and then we still have 6 to the 7th. But now we can't combine these because they're not like bases. And right now we see 3 different bases. We'd like there to be as few different bases as possible in any number. And so instead of having base 3, base 4, base 6, let's look at this 4 and think of a different way to rewrite that, as well as 6, using multiplication. Well, 4 can be written as 2 squared, and 6 can be written as 2 times 3. So if you look at all of these bases, here we have a base 3, here we have a base 2, here we have a base of 2 and a base of 3, because we're going to distribute that 7 like we did earlier. And so we have these 4 parts of this term, this one with a base 3, a base 2, a base 2, and a base 3. So we only have 2 different bases now. So we can multiply like bases by adding their exponents, and we can multiply the like bases with base 2 by adding their exponents. And so this would be one answer, 3 to the 13th times 2 to the negative 17th. But again, if we don't want to have negative exponents, we can rewrite that with this negative exponent term, they're part of the number, 2 to the negative 17. We could write that with a positive 17th power if we put it in the denominator. So basically it's flipping. Instead of 2, it's like 1/2. Number 7, x to the 0 is just 1. So we've got x to the negative 3, because here we had x to the negative 3 times x to the 0. So now we have x to the negative 3 times 1, which is just x to the negative 3, otherwise known as 1 over x cubed. In number 8, here again I've got a part of this number that's in the denominator, x cubed, and so I'm going to find a way of not writing this as a division. I can write this up above. Well, to do that I would change this from x to the positive 3. I could bring it up on top and write it as x to the negative 3. And the same thing with our y terms. So now you can see here I've got x to the negative 3. That's where it used to be in the denominator. Now I brought it up. And here this one, y to the first, used to be in the denominator. I write it as y to the negative 1. Like bases of x, I'm going to add those exponents. Like bases of y, I'm going to add those exponents. So I have x to the negative 1 times y to the negative 3. But if I don't want, this is a perfectly fine answer, But if you don't want it written with negative exponents, well, x to the negative 1 is 1 over x, and y to the negative 3 is 1 over y cubed, and so we can multiply those together. And now we have a value, or an answer that has no negative exponents. Those are problems 3 through 8 in the review sheet.